Okay, I want to demonstrate how to calculate the currents and voltages and power in a circuit that contains a single source, a battery, and 4 resistors, one series and then branching out through 2 resistors here, and this one is in parallel with the 2 resistors. So we'll call this one R1, R2, R3 and R4, and we'll call this 10 volts. That could be our supply voltage VS. So the first thing I want to do is to find any resistors that we can join together to make 1 out of 2 or whatever, so to reduce the circuit down, to make it smaller. We can see we have 2 resistors in series here. R3 and R4 are in series with each other, and we can just add resistors in series. So R3 plus R4 can make a single resistor, which I'll call R5. R5 is equal to R3 plus R4, and that's going to therefore be require some values. So I think the next thing to do is put some values up here. So we make R1 equal 25 ohms, R2 can equal 50 ohms, R3 equals 30 ohms, and R4 equals 20 ohms. So when we're adding R3 and R4 together, we'll have R5 will be 30 plus 20 equals 50 ohms. At this stage, what I want to do is I want to scroll this up a little bit, because I want to redraw that as a single circuit. It doesn't take long to do. By redrawing as a single circuit, we can very quickly and easily see what the next move is. It's not so easy when we've in our minds we know the resistors are being added together, but we can't actually see them. It's easy if we can actually just sketch it. So what I've done here is I've replaced R3 and R4 with an R5. So there's now R5. We've still got our R2 and R1. And we can see now we have 2 resistors that are in parallel with each other. It's quite easy to see that. R2 and R5 are in parallel with each other. So we can join those together now. Now the formula for parallel resistors is, let's call it RT for total, is equal to R1 times R2. Well, in this case it's going to be R2 and R5, so let's just correct that. There we go. R2 and R5 is what we want, so back to the pen. R2 times R5 over R2 plus R5. This is called product over sum, because when we multiply them we're getting the product of them. When we add them we're getting the sum of them. So that's going to be, in our case, R5 is 50 ohms and R2 is 50 ohms. So we could say 50 times 50 over 50 plus 50, which should work out at 25 ohms. In fact, when we have 2 resistors of the same value in parallel with each other, it always results in one resistor of half the size of any of the 2 resistors, so it should be half of 50 ohms. So we got 25 ohms as a result of that. And we can call that one R6. Just again, I'm going to very quickly sketch. So we have R1, and that's now just in series with R6. And we can see that these are in series with each other, so we can just add them. So that R total, the total of the circuit, we'll call it RT, will just be equal to R1 plus R6, which in this case is equal to, let's just scroll up and see what R1 was, 25, and they were 25, so that's 2 25 ohm resistors. So that's 25 plus 25 equals 50 ohms. Right, so we could draw that as a complete circuit, which I'll do on a new screen. I'll just clear this screen, scroll to the top. So we can draw that as a complete circuit consisting of one power source, that's our 10 volts Vs, and just one single resistor, a total resistance RT. And RT is equal to, and that was 50 ohms. And the reason for working this all out as a single resistor, a total resistance, is in order to work out what the current flowing from the supply is. So we can now work out the current from the supply. We can say that I equals V divided by R. If you can't remember how to do that, just write down little Ohm's law triangle with V on the top, I and R on the bottom. Turn it into a triangle. Little dividing line there. You can put a little multiplier if you want in there. And we cover up the one we're interested in. So in this case we want I, so we could cover up I. If you imagine I'm covering that with my finger, it's telling us that V must be divided by R. Now V was equal to 10 volts, it's the supply volts, divided by the total resistance of the circuit of 50 ohms. And that gives us 0.2 amps. I now need to have the original circuit again. So I'm just going to very quickly sketch the original circuit. A supply of 10 volts, R1, R2, I'll correct that in a moment, R3 and R4. So that's R2. I want to just get rid of that little shape there if I can. It's going to be quite hard without losing quite a bit of it, but it doesn't matter, I'll just draw it back in. And the values we had were equal to 5 volts. So we have 5 volts dropped across R1. We can see in our circuit that we have 10 volts applied to the circuit here and here. If 5 volts of it are dropped across R1, then the rest of it, the remainder, must be across here, from across R2 and across both R3 and R4. They've both got the same value of voltage across them. R3 and R4 have the same potential across them as does R2. So that means that R2 has 5 volts across it, and R3 plus R4 as a combined pair has 5 volts across them. So we can work out the current flowing in R2, and R2 is equal to 50 ohms. So if we have 5 volts across, we can find the current in R2. Let's call that I2 is going to be the value of, again refer to the triangle, I equals V over R. It's going to be the 5 volts we've determined is across that part of the circuit, divided by 50 ohms. So that's going to be 0.1 amps. And then the last bit we need to work out here is how much current, therefore, if 0.1 amps is flowing through here out of the 0.2 that's flowing down through here, the rest of it, namely another 0.1 amps, must be flowing down here, and that makes sense because it has the same resistance as a combined pair here as we have here, and if they have the same potential across them and the same resistance, they must have the same current. So what we're saying here is that I3, we can call it, if we look at this current that's flowing down through this leg here, that's I3. That must also be equal to 0.1 amps. And this 0.1 and that 0.1 add together to be the 0.2 that's flowing out of the battery. So 0.1 of it comes down through here. Another 0.1 flows through here. They both join together and become 0.2 again to go back into the supply.